have all these like libraries or packages that you're trying to install, there can immediately be issues where you're dealing with versions of packages or versions of Python or R or things of that nature, and I will talk about those. So what is renv? So from their site, it's a package that helps you create reproducible environments for your R projects. Should be a little bit of an asterisk there because environment isn't really defined, but and it's basically this special container. Python has it. If you're familiar with Python, they use something called virtual env. And you can just imagine it's like just this box that allows you to contain all the packages that you would use for a given project. Okay? So why do we need renv? So isolation. Again, if we can work on multiple projects, we don't want interference between all these packages, so we create that isolation. Reproducibility, again, name of the talk is reproducibility. Git gives us that. renv also gives us that. They give it to us in different ways. Simplicity. You don't want to be having to manage all of your packages at a system level. We'll talk about that. But having something like renv is greatly helpful. How many people use renv? Okay, good. So we got to the meat of the talk. It's going to be valuable for some people. So collaboration again. Remember with Git, we're tracking a lot of things, including libraries. renv helps us navigate those libraries, right? So we need kind of the both in concert with one another. So important renv concepts. There's library. So library is where your packages are installed on your system, right? So if you're on your computer and you're saying install.packages, whatever, it's installing it somewhere, and that somewhere is called a library. And we'll talk about the different levels. When you install R, there's a system level, and base packages are installed at the system level, right? But when you are a user, as you have a user on your laptop, and you say install that packages, it's installed in your user level, right? And they talk to each other. You can use base packages, that's not a problem, and you can use your user packages. When you're in a project, you can also have project level installation, right? And this is kind of where renv kind of comes into play. The other part is repository, and not to be confused with a GitHub repository. This is a different repository, but this is where you get your packages from. So CRAN, as we know, as a famous one. Okay? So without renv, what would happen? I have my project A. This is assuming I'm creating an RStudio project, and I say install.packages.dplyr. It goes through my computer, goes to the internet to go to the repository. It comes and it installs it in my user library, right? So now I have dplyr 1.4, right? Oh gosh, I have another project now, and I say install.packages dplyr, and I know these versions are wrong, but just bear with me. And it goes from the computer, goes to the internet. Now it installs version 2 of dplyr, but now I've broken project A, right? So if I want to go back to project A, I have to go install dplyr again, and then now I break project B, right? So this dependency on packages and their version, this is a simple case, right? You know that dplyr has a number of packages it depends on, right? And so having something like renv allows us to then isolate our individual projects so that we can install our packages and keep them separate. And so project A and project B can coexist on the same machine, and we don't have to worry about conflicts between package versions. And this is a very typical case. You might work on a project a year later, and there's like everything's broken because like your packages are updated, and now you have to either rewrite your code or you have to figure out how to revert your package versions, right? It's a pain in the ass. You can bleep that out. Where's the bleep when you need it? So this is kind of what renv does. It gives you this isolation. So where do renv and GitHub and Git, vary? So Git tracks all the things in our project, including our renv files. So now we're increasing our reproducibility. Not only do we have reproducibility from our just using version control, but now we get this additional value add of like, okay, now everything in my project is nicely bundled. I can hand this off to whomever. When they pull it, they can just effectively restore the project with all the packages and their specific versions, and we're off to the races. So working with RM, it's actually not like super complicated. There's really a handful of commands. I think that hopefully conceptually we've covered it a little bit, and so there's an understanding. But these are some of the commands. So we have this system library again we were talking about. When we do an rm init, it'll create that project library. So now we've created that bin. And there's a handful of commands for kind of moving back and forth between, because the state of your project is going to change over time. Maybe you're adding a package, maybe you're removing a package, maybe you're updating a package, and you want to capture that state. That state is captured in this log file. And there's a number of ways RM can interact with that log file. And then you can do also installations and updates using RM, which is a little bit more enhanced than just using install packages. Any questions so far? I feel like I should have just started with RM. You guys are all like, yeah, that's easy. And RM, everyone's like, oh, okay. So this is the installation setup. We can go through it if you like, or you can. Yes.
Sorry, I have a question.
Sure.
Have you ever tried to do RM restore on a project that was set up on one R version with, so now, let's say you are in a different R Studio environment with a different R version, and then you try, and then you pull the repo, and then you try to restore the RM. So that has not worked for me in the past, but is that supposed to work? If it was set up
I don't think so. Yeah, so I haven't.
Yeah.
We use Workbench, and so it's like our stuff is like administrated and managed in that way to avoid that. So everyone's generally working on the same R version because it's such a pain in the butt if you aren't. But yeah, if you, I mean, I guess philosophically or theoretically it shouldn't work, right? Because every time you upgrade your R version, those packages aren't necessarily then there. And in the lock file, it'll tell you what version the lock file was created with what R version. So I think most importantly is to make sure that that version of R exists. Now, what you bring up is a good point because you immediately see that like RM also isn't like perfect, right? And so this is where you get into this world of like, okay, well then Docker is what you can use to like then create a highly reproducible environment because the system level, so when I say system level, my laptop's different than Pop's laptop, different than Marlene's laptop. We might even all have Macs, but then the version of the OS is different or the year is different. So there's all these system level dependencies on the hardware, et cetera, that also help with your project. And so there may be limitations on what version of R or the way things are compiled may be a little bit different. And so with Docker, that helps you at least cover those system level concerns as well. And so that would be probably a better case. But in that one, I would just say probably just download that version of R and then it should hopefully work. So is it 8 o'clock we cut off?
Yeah, but you can.
Yeah, well, I won't belabor this too much. We won't necessarily do a hands-on for RM, but the commands are here for you to be able to set up RM. If you haven't already, I highly encourage it for all your projects. So install.packages RM will get that installed. You load the RM, and then you do an RM init. And so if we were to jump over here, I think I already have RM. So I'll just say, right, and then I say RM init. And it does several things. So it restarted my R session, but you'll see it created an RM folder. And inside of that folder, can you guys see that all right? It's a blurry screen, man. It has a library. Guess what? It has the packages. The packages that I install should be there. Of course, I don't really have anything in here because it's an empty thing. But that is created as well as I think it updates the git ignore. You may not. I'm not sure. It creates an R profile. That's what it does, which is activation for RF, so that when you initiate your R project, R Studio project, it knows to go initiate RM. And then it creates this lock file. So the lock file will highlight two things. It'll highlight the version of R as well as the CRAN URL that was used for your packages, and then it lists out your packages, and it lists the name, the version, what repository it was, which is again referenced here, and then it has a hash as well. And so this lock file is important that it gets committed so that when someone else pulls your project, they can then run that rm for store and restore the project by installing all those packages. Okay, and so and then we can also manage packages using rm. So if I wanted to install something, I can just say install, and then I'm going to say dplyr, but I know it takes a sec, so bear with me, I guess. Yes, I do want to install it. So what's the difference between using rm to install and install.packages? Rm actually goes to multiple repositories, so in case it doesn't find it. So bioconductor is not a common thing. It'll go explore bioconductor, and then it should also update your stuff appropriately. So now that I've installed the package, I say rm snapshot, and it says up to date already. So why is it not? I don't know why this does that. We installed dplyr, and we did snapshot, but it's not updating the log file. I don't know, pause it if you're listening, that would be helpful. And then we can also now I commit that lock file, and so whomever else is pulling the project is able to then pull it and resuscitate that way. So I would say let's get our hands dirty again, but Tuesday night I want to maybe go home. If you have questions, ping me. I'm on the Slack workspace, which I don't think gets a whole lot of use, but if you're on there, with that, I mean, I want to thank a lot of people. Obviously, the organizers. SoCalRUG is amazing organization for our users across Southern California, whether people are here in person or not. I think you guys are doing an amazing job, month after month, providing amazing talks, and I'm very appreciative for being asked to come, hopefully bestow some valuable information to you guys. And then the developers behind the tools. So Linus Torvalds, Junio, if you guys know Linus Torvalds. Who knows Linus Torvalds? Yeah, creator of Linux. As if that wasn't enough, he had to go create Git, right? And then Kevin and Hadley for RM, and then just the software development community. I think a lot of these things don't exist in isolation of just those individuals that have their hands on the computer. It takes a community, just the way you guys are here taking your time to engage with this content. So I hope it's valuable. So
Thank you.
yeah.
You get
Right on time.
the orchestra of weird sounds tonight.
Teapot. Are there multiple talks? Or is it just me?
Yeah, that's technical.
Oh, I was like, shit, I don't have an hour.
You have to produce multiple times.
Well, pretty much Git and RM are two talks, so you could have a full talk on either of those stuff.
Yeah, we just have one today. So, thank you everybody for being here today. We're gonna get started. Welcome to the Southern California Art Users Group. Today we have a great talk by Seb, version control, RM, and reproducibility. Again, that's the password. I'm gonna move on, but England, France, Greece, very simple. First of all, we want to thank our sponsors today. We have the UCI Paul Morash School of Business. They have been a great partner for us, providing sponsorship so we can, provide food, pay for a space like this. So we're thankful for their partnership. Another of our sponsors is the UCI Masters of Data Science. This is a newer program at the School of Engineering. I think they're in their second or third year, so still a new program, and they have been also a great partner for us. If you want to connect with us, these are all our socials, and in the interwebs you can find us here. We're in many different places. That link tree, that first one, link tree SoCalRUG, if you click on that, it's gonna take you to all of our different sites that we have. Some miscellaneous things. So some of you are regulars, some of you might come here and there, but we are looking for a new place to meet. Unfortunately, we're not going to be able to use this space anymore starting October this year. So we are looking for a new place to meet. If you know of something, please let me, Rebecca, or Emil know, because we are looking for a space. Yeah. Our next meeting is going to be September 26th. I think Rebecca just posted something. So that's a different Tuesday than when we normally meet. It's going to be the last Tuesday of the month. So just FYI. Another thing, if you have an idea of what you want to do here with the SoCalRUG users group, and you want to execute it, talk to us. We're happy to provide support, whether that is financial support a little bit, or mentoring, or trying to connect you with people. Yeah, again, if you have an idea, want to execute it, please talk to us. We're all happy to support. This is, this organization is for us, so we can benefit from it. To me, these monthly meetups are great, but if you want to do a book club, or want to organize some sort of workshop, or whatever idea you have, and you just need a little bit of support, just come talk to us and we'll try to make it happen. Okay, so today we have our speaker, Seb, that's Seton, kind of.
Works.
He's a PhD, has combined his expertise in the clinical science with his passion for computing to help create software solutions in the healthcare space. He deeply enjoys data exploration and analysis to help make better business decisions, increase efficiency, and to provide greater opportunities to patients. Seb has expertise in data science and analytics, as well as real-world data and real-world evidence. He believes there is significant value in leveraging RWD in many facets of healthcare, which will help reduce costs, improve patient access to drugs, devices, and trials, as well as drive deeper collaboration between stakeholders in healthcare. Seb is the Executive Director at RWE Analytics at Concert AI. We're grateful to have Seb, and time is yours, Seb.
Great. No, please. Hold the applause until after you see the presentation. Might turn into booze or something, I'm not sure. Thanks. Cool. So, hi everybody. My name is Seb. As Pablo very kindly did the introduction. Thank you to SoCalRUG and the sponsors for having an event like this. I think it's super great for everybody. Fantastic. You guys can see my mouse, okay? Okay, good. I'll just use that then. So yes, I will talk about version control, renv, and reproducibility. It seems to be a topic that people come reference me quite often. I don't know exactly why. I do have a passion for it, but maybe not that much. My LinkedIn is on here. Feel free to connect with me. I'm happy to help however I can. I also want to have a small caveat that I'm not as much of a developer as I used to be, so we're going to do our best, and this is going to be a little bit of a mixed session where I think the best way to learn a lot of this stuff is actually just to perform it hands-on. So we're going to all act as kind of one big, software data science team, and for whoever wants to participate, you have your laptops ready. You can do that. There is a repo if you're wanting to do this. If you want to participate, you could just go to github.com, and you can't probably see this, but github.com/PHDJSEP, and then /SoCalRUG-repo-recipes. So this is going to be the kind of fun repo that we're all going to engage with, and we'll do all of our Git stuff and our RM stuff. We'll come back to it later on in the talk. Okay, cool. So today's agenda. Why version control? Why reproducibility? We'll also dive into Git. We'll do a little bit of an intro for renv, and we'll do a little bit of a kind of hands-on with renv as well. Can you guys hear me in the back, by the way? You're okay? Okay. I also want to preface this that, like, for me, as an executive director, my position, like, I look for people that have an understanding of this, because this is a multiplier for both the person, for the group, and for the business. So this is kind of part of why, like, knowing this stuff is really valuable. And you'd be surprised how many people actually aren't as familiar as you might like them to be. So, importance. So how many people have used Git or are familiar with Git or like use it, like, you guys, and then how many are, let's say there are like advanced users of Git? Okay, how many are intermediate users of Git? 1, 2, and then how many are like beginners? Like, they've heard of it, maybe used it. Okay, cool. So definitely this is going to be geared to the beginners, intermediate. You guys will be able to participate, help along. Maybe you learn something with regard to how, if you don't have Git at your current businesses, maybe these will be valuable to, you know, showcase to your, you know, business leaders to say, look, we need a practice like this. This is a value, so you'll maybe see that. But basically, version control, it's just a system of record changes. We're basically tracking every little thing that we're doing. If you've used Word, Word has kind of its own little version control where you can kind of go back in history and be able to kind of recall something in case, you know, you need to do that. You'll see a lot of people that use Word that will be like _final, and then it'll be like _final, like that's their version history, right? Terrible, like move away, run the other direction. But this is critical, both in software and data science. So why is it critical? So one is collaboration. So very often we're not doing stuff in solo. And even if we are doing something solo, our future selves are gonna like kick us in the butt if we're not thinking of our future selves, right? And so version control is like extremely important for that reason. You're gonna work on something now, maybe you return to it 6 months from now and you're like, what the hell did I do? I forgot, right? And so having that system of record is really important. And with collaboration, verifying Microsoft Outlook, get out of here. With that, part of that collaboration is being able to, again, like people can now take a project and break it apart, and like everyone can kind of work on pieces of it, and you get scale that way as well. Most important, reproducibility, right? So now that we have a log of everything that's happened in a particular project, let's say it's an analysis, let's say it's an application, whatever, we can look back and it's easy for someone else to grab it and be able to like reproduce it because they have that same exact log for you. So it's vital for validation purposes, for example. And something we'll talk about later is libraries. So, you know, version control allows us to keep track of a lot of these changes. Experimentation. I mean, analysis is like quintessential use case for this, right? How many times is someone going to come request for you to do an analysis, and then you do the analysis and they say, okay, well, what about if you change these parameters, right? Okay, they go back to the drawing board, change the parameters, come back, and you get this back and forth all the time between someone who might be requesting something, or an analysis changes, or there's temporal aspects to your analysis. And so version control allows you to then take a split off of, maybe say, what you might consider your stable code, and be able to try out these different versions so you're not impacting your actual main code. So it's highly valuable in that regard. So experimentation, especially with analysis, super critical. Any questions so far? Is this all making sense? Yeah. Fantastic. Accountability. So especially when you have a lot of people that are working on something together, it's very easy to introduce, let's say, errors. It's very easy to introduce logical errors. And so with a set of version control, you can see what line was included by what person, and you can very quickly then identify how to make the fix. Maybe there was some misunderstanding in terms of how the logic should be applied, and it helps you, as a business, it helps you be able to kind of make those corrections rather than like go down a rabbit hole and then everyone's chasing ghosts trying to figure out what happened. So accountability is very, very important. Backup and recovery, obviously, since you can kind of go back into history, especially with things like GitHub, you now have a cloud-based version of whatever you're doing with Git. And so you have a nice backup in case your computer goes, blows up, you can always go pull your repository from GitHub and recreate exactly where you were at with everything. So that's how, GitHub works. And that is, trust me, it's happened, and it's very, very valuable. This one I like a lot. So again, with analyses and similar with software, when you have good practices at a company, reviewing code quality, reviewing code logic. In my area, we deal with real-world data. So real-world data is electronic health record data, genomic data, bless you, genomic data, a variety of things. And what companies are looking for, or what we are looking for internally, is trying to determine, let's say, a particular cancer indication. We're trying to determine what the outcome for that individual or individuals are. And there's a lot of nuance. Biology is not like super straightforward. And so how you define a particular stage of an indication may be different based on who you're talking to. And so you need a way, if you're going to especially build code, to be able to quality control, to make sure that the logic and the understanding of how that cohort is defined is accurate. And so version control and this whole process allows you for code quality before things get to production or into somebody's hands where they might not understand it. Any questions? Fantastic. Great. And the other benefit is like integration with other tools. Now you have this thing where you can start to do more fancy stuff like continuous integration, continuous deployment, things of that nature where, okay, great, we do this version control, we build our application, and then, Sep has to go and like deploy the app to the server, right? Like you can get rid of that. You can automate this whole pipeline so that once everything is approved, it's taken off, and you can integrate that with version control in those manners. So, yeah, I'm not gonna. I hate reading slides. I think it's like the worst presentation method ever. Part of these slides. Okay, cool. I see how it is. So part of these slides I built because we know that it's going to exist on the internet. I want someone to be able to pull them and read them and kind of have an understanding of the slides. But for presentation purposes, I just love to be able to talk to it. And this is a discussion, right? We're all here to kind of like learn and grow and level up. So let's like dive into it a little bit. We're going to talk about some of the concepts and some of the commands, things like that. If you're familiar with XKCD, lovely comic, especially within like the nerd realm, it's pretty funny. Can you guys read that? Okay. Yeah. Okay. So it's especially when people like getting familiar with Git. The joke here is that like, great, it's like this wonderful distributed graph theory tree model, and it's how it tracks things. Great. Okay. So how do we use it? I don't know, we just delete it every time and just like rebuild it, right? So don't do that, it's a joke, but it can feel a little bit daunting. I think for people that don't use Git and version control, once it clicks for you, you are like, why did I ever not use this? It's one of those tools that like, you absolutely should be using it for like everything. So anyhow. So I personally think that this like, analogy that I'm going to be using isn't necessarily the best one, so bear with me on it a little bit. But we're going to kind of simplify some of the concepts for people that might be not familiar with what version control might be. But in this case, we're working on a big puzzle with our friends, and we just want to be able to track how we're progressing on that puzzle. And version control is kind of like being able to take a picture of that puzzle as we go. So we'll talk about the term repository. Repository is like starting a puzzle. It's the box. That's the project, right? It's an analysis. It's a piece of software, whatever. And so that's what we're going to define as a repository. And then there's another term, commits. So commits are kind of like adding a piece. Like every time you add a piece to your puzzle would be a commit. This can be a little confusing, especially for people that are like, well, I saved my file, why do I need to commit it? Saving the file just saves it into memory of the computer. Committing is kind of like putting it on the ledger chain, so to say, right? So that Git can track it. It won't just track you just pushing Command S. And so, for example, each of these pieces here, I'm going to point, each of these pieces here could be theoretically a commit, right? That everybody's kind of taken, and then you could take a snapshot, move on, add a piece, take another snapshot, right? That's how it can work. Actually, before I move on, any questions on commits? Don't be shy. Okay, fantastic. This is going to be much faster than we anticipated. Then there's branches. So let's assume you want to try something, try a few pieces of that puzzle separately. Branching would be as if you took a snapshot of where you're at. In this particular case, let's say we're here, and we literally made a copy, and now we can start working on this new copy of the puzzle, right? Super, super valuable. Branching is very, very common, and the dumb basic use case that I would give in software development would be that if you were tasked with building a button for a website, you don't go build that button in the production code that's all stable, right? Because if you screw up, then you break it. You make a branch, you make sure it's all working, and then you make a request for that to be able to kind of move back into the main branch. So branching is an extremely valuable strategy. This is the part that kind of may mess with your head, because if you're used to being able to copy a folder and move it and then start working on that folder because you recognize that it's a separate space, that doesn't happen with Git. When you make a branch, that's the same folder and you'll see you're working in the same working directory. So yeah. Collaboration, version control allows everybody to kind of work on different pieces. So if you were working on a puzzle, you can imagine some people are like, okay, I'll work on the mountains, or someone else works on the lakes, and someone else works on the sky, right? You could all work on various pieces of the puzzle, and then you can bring that all together to complete your puzzle. And so same thing in software development. Someone's working on a button, another person's working on a form, another person's and you can immediately see that all of a sudden we get scale. It's not that everybody has to work independently. Okay, the button's ready, we can start working on the form. Okay, the button and the form are ready, we can start working on the submission, right? Everyone can kind of work in parallel and be, and we're talking about things that allow hundreds of developers across the world to be able to, program simultaneously and develop the amazing tools that a lot of us use. So highly, highly powerful stuff. I may be just preaching to the choir. Hopefully this is novel or at least interesting for you guys.
Quick question, Seth.
Absolutely.
On collaboration, have you had experience with Git, but not with a commercial software? So just Git. Does that make sense? Like collaboration with just Git, without GitHub, without GitLab, without Bitbucket?
I see what you're saying. You can set it up. It's remarkably difficult.
Right.
Right?
The reason why I'm asking is in a previous company that I worked, we were working with government classified data, right? So we couldn't use GitHub, Bitbucket, GitLab, all these companies, because of the type of data that we were dealing with.
Yeah.
So the idea was to try to use, we were producing code, but it was difficult to collaborate because the only thing we could use was Git, pointed to like a local server,
Yeah, you could do it on-prem. So if you had an on-prem server, the Git would still work, but it takes a little bit, I think, of finagling to get it to work. But this is why there's so many of those valuable companies like GitLab and GitHub and things like that. Thankfully, for most use cases, that works.
Right.
But yeah, I mean, with everything in software, you're always going to have some edge case. But that's a good point. Anybody else have a question or also kind of work in a restricted arena that prevents them to use version control? Cool. Great. And then the other thing is we talked about history, right? So we get to track all the moments and all the things that we've done to build that puzzle piece by piece. And so that could be line by line, could be function by function, could be file by file, however you like to do it. There's a little bit of art for committing, by the way, but we won't get there. And then and as we talked about backup, so the funny analogy here is, let's say you're working on the puzzle and your nephew or brother or whatever comes and starts drawing all over it and spilling things over it. Well, we can always revert back and be able to recover that item. So yeah, so that's kind of the concepts of Git. I'd love to be able to just jump in and as a group be able to start using Git and answer any questions. We'll spend some time doing that and getting familiar. This is a safe space, no egos. Ask your questions, break things. We have enough manpower here, or person power, excuse me, to be able to fix things. I forgot. So these are a little bit more technical. I wouldn't worry about it too much, but this basically exemplifies some of the I guess processes for the commands that we would be running. Is it? Oh yeah, I forgot there's like jujitsu upstairs, right? So the red block here is your working directory. So this is the project directory that you're working on, the folder that you're working in, whatever. From there, whenever we make kind of a change or something, we can add those files into what they call a stage. And this is where things get like tracked in a way. And then from there, once we've staged everything, we can commit that to history. And that's kind of like locking it into history. Now, lock might be an extreme term. There are ways you can kind of unwind and do that stuff, but it's difficult and kind of annoying. So you want to make sure that when you're committing, you know what you're committing. And then you can also kind of work backwards from history to stage to working directory. So you'll see some of these commands. We'll go through them, but just to kind of showcase some of that. And then branching, again, this looks complicated, but it's really not. Again, the red box is what you see. This is your project directory. Once we've kind of done some work, we can add it to the stage. This is the purple or blue. And then once we've done that and we commit it to history, you start to get this green chain. So remember, the green block is history. This is an expanded view of that history block, and you get this. You get these this chain of items that you've committed to history. They are all tracked with a hash, and so don't get confused. Don't let the hash kind of scare you. The hash is basically the way you can make sure that that particular unit in history is unique, right? And so from this history chain, we can create branches, and there's all kinds of things. I don't want to go into too much of that. It gets a little bit confusing, but effectively that's it. So, any questions on that? Cool, awesome. So yeah, let's get our hands dirty a little bit. So go ahead and start up a new RStudio project if you have your computer handy. This is the URL now. Hopefully that's much more readable. And then when you start up your RStudio project, make sure you create a project, and then just select version control, paste the following, and you'll immediately have cloned the repository to your local machine, and we can begin working there. And let me know when you guys are ready, and we'll just kind of switch screens. And this is going to be fun because it's like, however many people are, raise your hand if you're going to participate. 1, 2, 3, 4, 5, 6. Cool. We got like 7 people that are participating, so it's like a software team all kind of working together, and we'll see how we can kind of like work together and like gather information all at once. Alarm's going off already. Okay, cool.
This is a test of emergency broadcasting.
Yeah, it's a test that your talk sucks, Seth. Okay.
More like if you swore for a really long time.
Yeah.
You out.
Yeah, I should just like be talking but like quiet out when everything goes down. It'll be perfect. You don't have to do post editing or anything. Okay. So once you guys are in there, let's go ahead and create a new file. So file, new file, and it'll be a text file. It's fine. We're not doing anything fancy. And go ahead and you can use Markdown if you want, and you can put in your recipe name. So Sep's baking recipe or whatever. It doesn't matter what it is. And then if you want to copy paste something, or if you want to make something up, you're welcome to. I'll just say I'm going to put ingredients. I'm going to say eggs, vodka. What else can we? Cilantro. All these disgusting things that we're going to put in together. We'll put chocolate in there just to make it a little bit. Okay. And then we're going to do instructions. You don't have to follow what I'm doing. Feel free to be creative and add whatever text file you want. We're going to say put...
Drink vodka and the rest won't matter.
Oh, yeah, perfect. Okay, yeah, we'll do that. Drink vodka, toss the rest. No. Toss eggs and cilantro, and then enjoy chocolate.
It's a good recipe.
Honestly, it's not terrible. And then I'm just going to say, Sep's recipe dot text. Cool. So you can use the Git in the RStudio IDE if you like. I don't like using it. I prefer my terminal. See the terminal? Okay. Should I make it bigger?
Okay.
Is that better? Okay. So once you've added your file, one of the first things you can do is git and then status. Okay? And this will show, it'll give you some information. It'll tell you what branch you are on, and feel free to stop me if you aren't there, or I'm going too fast, or...
This is all the command line, right?
This is command line. This is no different than going to your, where do we go? Terminal. Where's terminal? Oh. Where's terminal? Okay, now it gives me terminal. This is no different than using your terminal in RStudio. I can show you how the UI works if you want to do that. But I highly encourage people to use the terminal because there's much more control. You don't really know what's running behind the scenes of an IDE. So is everyone here? Is everyone kind of following along? Yeah, go ahead.
Can you have the repository?
Sorry?
Can you have the address of the repository again?
Can I what?
Link the URL.
Oh, the URL. Yeah, sure. This one?
If you have time, can you talk about how you get your terminal to show what branch you're on?
Yeah, sure. When Javier was asking me to give a talk, he's like, dude, you should talk about the terminal setup that you have. And I'm like, no one's going to care about that. And then, of course, someone asked about terminal setup.
I think you can do it in your RStudio in your R profile or something.
What's that?
I think you can do it through R2 somehow, but I don't know how.
Yeah, I find so you can configure your terminal in RStudio, but
You don't like it.
yeah, because I already have the hotkey for swapping between my terminal, and it's already all nice and configured, and I'm just faster that way. I have to then I don't know the hotkeys for swapping my views in RStudio, so, and I generally tend to work in VS Code anyway, so it's too many IDEs to worry about. Do you have the URL now? You good? Okay, cool. And then have you created a text file? You're all set? You're setting that up? Is everyone on the same page? Because this is the one part where I want to make sure we're not losing anybody. Yeah, okay, cool.
Um,
Yeah,
Okay,
go ahead.
so my RStudio, this this computer I haven't used for a long time
Uh-huh.
isn't working.
Don't make excuses. I'm kidding.
So I went to Posit Cloud to try to use, like, you know, our studio-like thing on
Uh-huh.
here. And how do I, does anybody use Posit Cloud to create a
Project?
project?
I'm in
It should be the
Polygon
same.
right now.
Oh, are you?
Yeah.
Okay, I'll ask her.
Yeah, good. No worries. No worries. Cool. So I'll move forward. So, so when I do like a git status, that'll tell me like what branch I'm on. So in this case, I'm on the main branch. It tells me that my branch is up to date with origin main. In this case, that means GitHub, like the cloud. I'm up to date with the cloud. And then it says, hey, you have some untracked files. So what are untracked files? Remember we were talking about working directory and then staging and then commit, right? So that means these files Git has identified as being different. Like I haven't been tracking. These are new to my repository. And if you can't commit them, right? You have to stage them first. So if I say git add, I can name the files one by one if I wanted to. In this case, all of them are appropriate. I'm going to hit dot, which means everything in this that's unstaged or untracked. I hit add. Obviously, my IDE or my terminal is a little bit configured to give me these like pretty little, like it tells me what branch I'm on and what needs to happen, etc. But you can just do git status, and now it says, hey, here are some new files that I'm tracking. Now, what would you like me to do, right? And so at this point, I would say, okay, cool. Why don't we commit that? I'm done with that, and we'll just say, you know, added our studio project. This little -m flag just allows me to add the message in line in one fell go. I don't have to hit git commit, and then it takes me to an editor, and I add the line, and then it brings me back. It's like a shortcut. So I say git commit. Okay, cool. Now what's happened? That commit has added to my history locally on my computer. And I can look at my history by saying git log, and I see, remember those hashes that we were talking about? I see that this is what I just committed. I said added to our studio project. It tells me where I'm at. This is where my main branch, the head of my main branch is. And it also tells me, hey, like your origin, the GitHub, it's actually behind. Okay? And so this gives me that log. Remember we're creating this chain of commits? That's where it gives me this log. So if I hit quit, or Q, it exits out. My terminal also tells me you're one commit ahead of your remote area, remote branch. And so at this point I would just say git push, and ta-da, it's pushed to GitHub. If I do that git log again, you'll notice that those commands are now, everything's up to date. The remote branch and my local branch are the same. Okay? And yeah, and so if we go to GitHub, we'll notice those files are there. It says, oh, it's been a minute ago it was there. Okay, great. So now here's the tricky part. Not that tricky, but caveat. I've now added a change. If you guys pulled it before that change, you don't have that change, right? And so now we need to be able to pull what I just added. And guess what? It's called git pull. So if you go over to your terminal and you say git pull, it should, well, mine's already up to date, but yours should pull your things. Yeah, go ahead.
It was asking for username and password when I was trying to push.
Oh, yeah, thank you. That's because I haven't enabled everybody to push it. So you're going to want to pull before anyways, but let me change that setting so it's available for everyone. Thank you for bringing that up. What do we got here? Okay, visible to anybody. How do I open this up?
You can't open it up to everyone.
Do I have to add people?
You have to add people.
What? I don't want to do
Isn't
that.
it public?
Yeah, can't you make it public?
When it's public, it means it's publicly available, viewable, and you can pull, but you can't pull.
Yeah.
You can change that though.
You can add.
You can add collaborate.
I thought there's a way to open it up where you protect your main branch and everyone else can make a pull request.
What they should do is they should clone it.
Yeah, which they
And then
did.
they do a pull request back to you.
Yeah, so they've pulled it, they have it on their local computer. And so they can make a pull request, right?
Then they would make a pull request.
Yeah.
Or instead of us trying to push, instead of
But you
the
have to
git
fork it
push
first.
would be,
Sorry?
You just can't pull it. You can't just clone it. You have to fork it.
Oh, I don't think so. I think you can clone it. The fork would be if you were going to go work on it separately.
If you created the project, it means you're connected. You can pull, but if you have committed, you have to rebase.
You have to rebase, yeah.
Yeah,
So we'll talk about rebase for sure. So because you guys have already added a file, you'll want to
Yeah.
rebase. You
So
go
I think it worked for me. I pulled, I rebased. I
Okay.
have conflicts, but
Yeah. So did you? But yeah, we'll figure out the conflict. This is the fun part about workshopping, guys, because this is like real world. Like you're gonna get this. It's not gonna go smoothly, but we put our heads together to figure out those things. Let me see if I can. There is a way to. Here we go. Of course. Add branch protection, there we go. Main, require pull request. Okay. Okay, so are you on the main branch?
I think so. I don't know. I just copied the link, created the project, and I committed and I pulled. So I think I'm just main branch. I didn't create a branch.
Okay, so
Yes, the answer is yes.
yes. So you're on main branch. So what I want you to do is do git branch -d and then name your branch.
all of us or just him?
All of you can do it actually.
Git.
Yeah. I think it's -b-d. Wait, no, it's not -d. It's -b.
It should be B.
Yeah. Yeah.
Lists the branch.
No, git branch will list the branch. We don't want that. We want to create a branch. So we say git branch -b, and then I'll just say test branch, whatever. Or did it not work?
To name it and switch to it.
It's
Git
not
checkout.
It's not D. It's not B. It's
It's not B. It's
oh wait.
Git
Git checkout.
Git
Sorry.
checkout minus B.
My God, it's been so long. Yeah, it's git checkout -b. Sorry. Do git checkout -b and then name your package. Or name your branch. Sorry. So if you want to call it like SEPs branch or whatever your name is, do that. Okay. Now let me know when you guys have done that.
Once you create that, once you do that git checkout, you automatically switch to that branch?
yes.
Yeah.
Yeah, it should automatically. So if I did git checkout -b and then test branch, you'll see that my branch immediately changes to test branch. Okay.
All right.
So this is kind of that little inception thing that I was talking about before. There's no need to copy my folder somewhere else and be able to work on it. I am now working in an entirely different branch, but it's exactly the same stuff that I had it previously. So if I wanted to create a bunch of files, right? Right. So now I have things in there. I can do git checkout main, and those files are still there, but they're not tracked. So, right, I can move between them. And here's actually probably a better example would be the what did I call it? Test branch, yeah. Perfect. So if I do git add git commit dash m. Okay, so now my test branch is clean and it has those two files, right? If I do git checkout main, I don't have those two files. I'm in the same directory, but Git is allowing me to track different variants of the same project. This is like highly, highly valuable. And so you can imagine a data analysis where you're doing something and you need to, maybe I want to test a package, or maybe I want to build a function, but I don't want to impact what I've worked on. I can build it over there. Once I have it working, or maybe it doesn't work at all, I don't have to worry about it. I can blow it away. I can say git branch -d, that's where we were at before, and I say test branch, and it's gone. It said, in this case, it gives me like an error. Say, hey, you didn't merge it. Are you sure you want to delete it? Okay, then I just have to use capital D, and it's gone. And now if I look at my branches, it's just my main. I'm back to where I'm at normally. Okay, super, super powerful. Cool. So has anybody been able to like commit or push or anything like that?
We have a question back here.
Yeah, sure.
Some of us are getting a message about the fact that, so I first got this earlier when I was still thinking out about push main. And when I did git pull after you mentioned it, got an error message. The following untracked working tree files to be overwritten by the merge. So I'd already committed. And
Yeah, so do a git pull and then dash space dash.
Yeah,
Oh.
that works.
Oh.
Yeah, so it did say error about the git ignore, but my git ignore and your git ignore look the same. So do you know why that comes up?
Yeah, I mean, sometimes Git can be a little bit conservative with respect to like collisions on files. And so it'll like elevate any particular merge conflict like that. Is that a merge conflict that you're getting?
It says it'll be overwritten by the merge when I was trying to pull your.
Yeah, so it'll say my git ignore is going to overwrite your git ignore. Yeah,
But they
and
look the same.
does it allow you to proceed?
It's because of the time, I guess.
Yeah,
the
there's
time
a-
that you save.
There's a variety of factors, yeah.
Oh, okay. Okay, good. Just trying to understand it. Yeah, I can get out of it. Like,
Yeah.
and I wasn't even trying to.
Yeah, go ahead.
So what's the best way to remove the conflicts? I know I can go and remove the conflicts manually to make it the same, but what would be the best practice?
So Git has some commands where you can say accept theirs or accept, I think, mine, and so that allows you to like, because if you look at I don't have a Git conflict on my screen. I'm not sure if I can generate one. Let's see if I can pull and someone's committed or not. So when you get a conflict, let me see if I can dummy one for you guys. When you get a conflict, it'll look something like this,
Right.
and it'll like, this will be your contact. It'll say something like main, and then it'll be whatever, and then
Equal sign.
is it equal? I don't remember.
Equal at the end and equal at top.
Yeah, and it looks something along this line, and it'll be like whatever, some other branch name, and this will be the conflict it highlights in the code, and so it's up to you to then select whether you're like, no, this is the right one, let me get rid of this stuff, and then make that commit, or you could say, no, the bottom one's actually the correct one, and I want to accept that. So Git has this command, so rather than you have to manually go in and change those things, Git has a command where it allows you to then say, accept all of my changes, like forget the other person, they were doing it, it's old, whatever, or accept theirs, mine is what needs to be overwritten. And you can do that wholesale. Of course, not everything works that way, where maybe sometimes you want to keep your stuff, other times you want. There are utilities that allow you to iterate through each particular conflict if there are multiple, and then select, mine or theirs. That's, I didn't know we would maybe get to that in this particular talk. Honestly, like both Git and RM are like you could have a whole hour discussion on this, and I really wanted to just touch on it, explore some concepts, and mainly from like a perspective of like why these should be used, talk about them. So totally happy to answer questions, but I also won't recognize it's 7:50 and we still need to talk about RM. Cool? Any questions? Awesome. So, we didn't get to everything, and I encourage you guys. This repository is like a throwaway repository. You guys want to commit stuff, play around with it. I highly encourage you to get your hands dirty. This is the only way you're really going to learn Git. And when you have questions, just ping me. I'm happy to guide you and fix that. But let's move on. So we've done all this amazing stuff with Git. We can do tracking and version control. We can do history. We could collaborate, all of these things. So what the hell do we need RM for, right? Well, RM is like super critical. When you deal with languages like Python and R,